Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I will be going over how to determine whether a salt solution is going to be acidic or basic or pH neutral. So we've been talking in previous videos about individual ions, cations, anions, whether or not we can determine if it'll be basic or acidic or pH neutral. But what if you have a salt solution with both a cation and an anion? How do you determine that? Well, you determine it with the exact same way as you determined it with the ions itself. The only hard part, or where you're going to have to do a little bit more, is if you get an anion and a cation in the salt that are both basic and acidic. So we'll talk about how to do that. So the way you're going to do this is you go through and you look at each individual ion in the compound, and you determine, did this come from a weak base, a strong base, a weak acid, strong acid, and you determine it that way. So let's begin with A. So here we have strontium chloride. Strontium basically is the cation of a strong base. So your strong base would be strontium hydroxide. So strontium is going to be pH neutral. The chloride ion is the anion of a strong acid. So that's going to be pH neutral. So we would expect this salt to be pH neutral. So we would say pH neutral. What about B? So we have aluminum 3+. That is a highly charged and small metal ion. So aluminum 3+, highly charged, small metal ion. We've learned from that is because that would be acidic if in solution. Because the water is going to cover it, and what's the one I'm looking for? It's going to be surrounded by water. It's going to be bonded to water, and that's going to cause some of the water molecules to release hydrogen. So we would expect this to be acidic. So we said this was pH neutral. This is pH neutral. So this is going to be acidic. Bromium, again, is going to be the anion of a strong acid. So that means that the bromine is going to be pH neutral. So we have an acidic ion, we have pH neutral, so the solution here would end up being acidic. Okay, what about C? C, we have CH3, NH3, NO3. So CH3, NH3, that's an amine. CH3, NH3 plus. That is an amine. Well, it comes from the amine. It's the conjugate acid of an amine, which is a weak base. So this is a weak acid. So we would expect this to be acidic in solution. And NO3 comes from the strong acid, HNO3, nitric acid. And we would say that, therefore, the NO3, the nitrate, is going to be pH neutral. So this is going to be acidic. So that salt would be acidic in solution. What about D? So sodium is the cation of a strong base. So this is going to be pH neutral. And this ion comes from formic acid. So HCHO2, which is a weak acid. So therefore the CHO, this CHO2 is going to be basic. So we would expect that to form a basic solution. So this salt would form a basic solution. Now what about E? E, we have NH4, ammonium, that's NH4 plus. This is the weak acid or the conjugate acid of a weak base, ammonium or ammonia. And so since ammonia is a weak base, this is going to be a weak acid, so this is going to be acidic. And F minus, the fluoride ion, is the anion of a weak acid, HF, right? So HF is a weak acid. That means that the fluoride ion is going to be the conjugate base. So that means that we would expect this to be basic. So we have an ion that's going to be acidic in solution. We have an ion that's going to be basic in solution. How do we figure this out? This is where we need to compare the Ka value of this conjugate acid with the Kb value of this conjugate base, and then see which one is larger. And the one that's larger is going to be the one that rules the solution. So we find the Ka value of ammonium, and we're going to use the equation Ka times Kb is equal to Kw, which is equal to 1.0 times 10 to the negative 14. So we look up, to find the Ka value, we have to find the Kb value of ammonia. So that would be 1.76 times 10 to the negative 5. So that the Kb value is 1.76 times 10 to the negative 5. So that means that the Ka value for ammonium is going to be 1.0 times 10 to the negative 14 divided by 1.76 times 10 to the negative 5. And so the Ka value becomes 5.68 times 10 to the negative 10. So this is the Ka value for ammonium. Now we need to find the Kb value for the fluoride ion. So for HF, the Ka value is 6.8 times 10 to the negative. So here, the Ka value for HF is, what did I say? 1.5 times 10 to the negative, nope, hold on a second. It's going to be 6.8 times 10 to the negative 4. So 6.8 times 10 to the negative 4. So then that means the Kb value is going to be equal to 1.0 times 10 to the negative 14 divided by 6.8 times 10 to the negative 4. And so the Kb value is 1.5 times 10 to the negative 11. So 1.5 times 10 to the negative 11. So this is the Kb value for the fluoride ion. This is the Ka value for NH4 plus. So now all we need to do is see which one is bigger. So obviously 5.68 times 10 to the negative 10 is a larger number than 1.5 times 10 to the negative 11. And so therefore the Ka is stronger. That means it's going to be acidic. So finally we determine that it is going to be an acidic solution. Okay, now for the others, let me erase this, make some room. All right, so F. sodium, and this is the anion for for carbonic acid. So this is hydrogen carbonate. So sodium hydrogen carbonate. So again, sodium is the positive ion, the cation of a strong base. So then this is going to be pH neutral. Okay. This here, it comes from carbonic acid, CO3, H2CO3. Carbonic acid is a weak acid, so that means that the anion is going to be basic. So we got pH neutral and basic, so that means that the salt, this will form a basic solution. What about G? So here we have this part here, that's going to be the positive ion, CH3, CH2, and H3 plus. And so just like with ammonium, this is going to be acidic because this is the conjugate acid of a weak base, which is, looks like ethylamine. It's an amine. So this is going to be acidic. And the Cl here comes from the strong acid HCl. So it's the anion of a strong acid, therefore this is going to be pH neutral. So we have acidic, pH neutral, so the two together is going to be acidic. So we would have an acidic solution for this one. What about H, KNO3? So potassium here, potassium is the positive ion of a strong base, KOH. So that means that the potassium is going to be pH neutral. And NO3 is the negative ion of a strong acid. It's the anion of a strong acid, therefore NO3 is also going to be pH neutral. And so the solution for this salt would be pH neutral. And then finally, what about iron and this iron 3 nitrate? So iron 3 plus is a highly charged small metal ion. Therefore, it's going to be surrounded by water. Water molecules are going to give off their protons, their hydrogen, and that's going to make it acidic. So these are acidic. And again, nitrate, as we said before, is the anion of a strong acid. So this is going to be, again, pH neutral. And so the two together, we would expect the solution to be acidic. And so that's how you figure out whether or not the salt is going to be acidic, basic, or pH neutral. I hope this is helpful. If you like these videos, please like, share, subscribe, hit the notification bell, make a comment in the comment section. Thanks for joining me. I'll see you next time.